All right, Algebra 2, we're talking about Chapter 10, Section 2, Parabolas. We want to start with a basic definition of how you even create a parabola. So there is, anytime you have a line called a directrix and a focus, which is a point, you can create a parabola. So it really only takes a line and a point. Now, this point and this line are not actually a part of the parabola, but they are used in actually creating the parabola. So let's just see how this works. We need every point that we can find that have the same distance between that point in the focus and that point in the directrix. So let me find the first one. Right there is the first one. It has the same distance here as it does to here. So that is one of the points on our parabola. In fact, that particular point is kind of important. We call that point the vertex of the parabola. It is the point where the parabola changes directions. Now, I will tell you that this is a point also on my parabola. How do I know that? Because the distance to the focus is the same as the distance to the directrix. This is a point also on my parabola, because the distance to the focus is the same as the distance to the directrix, or approximately. I think it's a little bit far. Probably more like there. That looks better. Every point that you can find where the distance here is the same as the distance here creates this shape called a parabola. So the focus and the directrix are very important to that. Now, the distance from the vertex to the focus and the distance to the directrix is called c. We use the letter c to represent this distance, which is also the same as this distance. So the letter c for both of those. And you'll see how that plays a part in the equation and all that good stuff here in a minute. There are a couple different types of parabolas that we are going to be dealing with. You are very much used to dealing with this one over here. We talked about that in Chapter 5, y equals ax squared, where in this case, a is a positive number, right? A is greater than 0. We've also dealt with the upside down version where a is less than 0. Still y equals ax squared, but a is less than 0. The ones that we haven't talked about are the other variety, where x and y are switched. If you switch x and y, yes, we're talking about an inverse, right? Because when you switch x and y, that's what happens. You get an inverse. This is the left and right opening variety. So we have the up or down opening one over here, and we have the left or right one. Of course, this is a is greater than 0, the positive direction. And when it goes to the left, that would be you're less than 0. Still the same equation. Oh, one other piece of information I want to just tell you or remind you of. The focus is always inside the parabola, and the directrix is always on the outside of the parabola. Focus is always inside, directrix is always outside. So in every one of these situations, there'll be a focus and a directrix, which remember are not really part of the parabola, but they are important in finding the definition of that parabola. So every one of these has a focus inside and a directrix outside. Now, if you can tell, this would be a horizontal line, y equals a number, and these would be a vertical line, y equals another number, or x equals a number. So we have to draw the pictures. That's extremely important. So in example 1,